Hello guys, in the previous video we discussed the basis path testing. Right? I hope you people understand what exactly the basis path testing is, because that basis path testing is very important, because for theoretical point of view also, as well as the lab program also. People know, right? The last three programs, uh, binary search, quick sort, and absolute letter grading. These last three programs based on this basis path testing. So the main thing is, if you heard the term basis path testing, you should remember the equation v of g is equal to e minus n plus p, or v of g is equal to e minus n plus 2p, based on whether the source whether the last node is connected to the first node. If the last node is connected to the first node, then the formula will become v of g is equal to e minus n plus p. Instead of 2p, it's only p. So here v of g is vector space, e is equal to what? Edge, number of edges, n is number of nodes, and p is nothing but the reason. Always remember, the p is always is equal to 1. Okay, this is regarding what? The basis path testing. So we know what exactly the basis path testing is. Let us discuss in this video what are the issues of basis path testing and what are the advantages of basis path testing. Later on we will discuss the other testing approach called Dataflow testing. Okay, now let us discuss the issues of basis path testing. Okay, so the first issue is linear combinations of execution paths are counterintuitive. What is mean of counterintuitive? So linear combination, for example, if you say 2p2 minus p1, what exactly this means? Whether you're going to subtract p1 from 2p2, or whether you're going to multiply 2 with the p2 and you do the other operation. So these are all some kind of confusion that may arises when we conduct the basis path testing. This is the first issue. The second issue is regarding how does the baseline method guarantee feasible basis path. Of course, in one or two problem, or most of the problem, you can achieve that one, but you can't guarantee that in every in every possible situation you're going to achieve, or you're going to find the solution using this basis path approach. Okay, that's why it doesn't guarantee this one. So the third one is, given a set of feasible basis path, is this is a sufficient test? You are going to say this whether in a given set of feasible basis path, okay, you're going to find whether this test is sufficient, or you can't have any proper method to achieve this one. Okay, this is another issue. So let us discuss the advantages of this basis path. So McCabe's approach uh, does address both gaps and redundancies. Of course, it will cover the gaps as well as redundancy when we are actually discussing this basis path. Second one is regarding what? Essential complexity leads to better programming practices. Okay, essential complexity leads to what? Better programming practices. So if you have some complexity in this program, then it actually means that you are following a better programming practice. If you are actually going to solve the complexity, then you're going to actually what? You're going to solve the problem which follows the better programming practice. So McCabe proved that violations of the structured programming constructs increases cyclomatic complexity, and violations cannot occur singly. Okay, this is another approach. So he actually proved that violation in the structured programming construct. So when you're actually writing the program, structured programming construct, if you make any violation, it will actually increase the cyclomatic complexity. Cyclomatic complexity in the sense, it will actually increase the number of independent path, number of linearly independent path, which in turn it always these violations cannot occur singly. If you have a number of more independent path, of course you need to execute more number of test case execution. That's why it actually assures that this basis path approach assures that you are actually following the structured programming approach in a right way. Okay. So now we are going to discuss the other approach, the third part. Okay. The second part is also there. The first part is regarding what? The statement coverage, branch coverage, and condition coverage. That is first part. Second part is regarding the path testing. This is actually the third part, the last part. It actually related to the data flow testing as well as slice based testing. Okay. What is data flow testing? So data flow testing and path testing, assume what exactly the path testing. So in the path testing, you are going to test the execution path of any programming construct, right? So a program is there, you're going to represent that program in the form of a program graph, and you're going to check according to the execution, you're going to follow the different path. If the condition is true, it will follow one path. If the condition is false, it follow another path. This is regarding path testing. The main approach, the main idea of this path testing is, of course, which actually resides in the basis path approach. Okay? So if you have a basis path approach, then there is no need to execute all the test cases. Only you need to find the number of independent path, right? Only you need to find what? The number of independent path. That is more than enough. If you cover the number of independent path regarding the test case executions, then you can actually cover the entire program statements. Okay, that is the idea of path testing. This data flow testing. What is exactly this data flow? The name only tells, right? Data flow. So in which way the data actually flowing from one point to another point. So we are going to conduct test based on the flow of data. Okay, this is the first point you should remember. This data flow testing often confused with data flow diagrams. So don't confuse with the data flow diagram. Okay, data flow testing is different, data flow diagram is different. So main concern here is places in a program where data values are defined and used. So at which point you are going to define a variable? That is one point. At which point we are going to use that variable? That is another point. So these two approach are actually the main thing in this data flow testing. When the data are actually flowing from one point to another point, you need to find a point, you need to find a place where data is actually defined, and you need to find a place where the data is actually used. Okay, these 2 points are very important. Okay, so static, that is nothing but as compile time, and dynamic, the execution time version. There are two versions, static versions, dynamic versions. In the static versions, so the define or reference anomalies on a variable occurs. Okay, what is this kind of define anomaly, reference anomalies? For example, if the variable is defined but never used, you actually define a variable but you will actually never use that variable, that is considered as a what? Static anomaly. The first point of static anomaly. And the same variable is used but never defined, but you will actually use that variable but you never define that variable. There is another anomaly. If you use that one, if variable is there, the variable is defined more than once, this is called multiple occurrence, right? So these are all three defined reference anomalies. To avoid this defined and reference anomalies, we are going to conduct data flow testing. The first point tells you that you actually defined a variable but you will never use that variable, you never reference that variable, right? If you define that one, If you never use that one, there is no point here, right? This is also considered as an anomalies. Your program will show some warning, right? You actually define a variable, but you never use that one. Even though it's not a error, but you never use that one. Of course, it's a wastage of memory, right? That is also a part of first anomalies. Second is actually error. Second and third. In the second, you actually use that variable, but you never define. So definitely your program will throw error like, you're actually using a variable, but you are not actually you don't define that variable. This kind of error you definitely going to check. You're definitely going to get. Okay. Third one is you're actually at multiple point you define that variable more than once. So to avoid this one, you're going to conduct the data flow testing. Here the starting point is a program, okay, P, with program graph G of P and set V of variables in the program P. So P is nothing but program, G of is a program graph of that variable, V is nothing but a variable set. So interesting data flows are then tested as separate functions. Okay, the data flows which are actually considered and tested as a separate function. Okay. So definition, you people know, right? Definition, of course, you just define program P and V set of variables, and G of P is nothing but program graph. Node N is which is belong to the program graph. I should this remember this one. Based on this one, we are going to define the node. Okay, a defined node is there, a usage node is there. We are going to define both the nodes. A defined node of the variable v, which belongs to the set of variables v, written as def. Define variable v at node n, def v of n. Def vn, if and only if the value of the variable v is defined at the statement fragment corresponding to the node n. Okay, then only you can call it as a defined node. So usage node, one point you define. I already told you, right? There are 2 points. One is where you actually define, and the second point is where you actually use that variable. That's why there is two nodes, two variables: define node as well as usage node. A usage node of the variable v, which belongs to the variable set v, written as use v of v comma n, if and only if the value of the variable v is used at the statement fragment corresponding to the node n. Simple thing. So write d of vn, right? Use vn. d of vn is defined point. Use vn is you actually where you are actually going to use that point. User point. Okay. So a usage node use vn is a predicate use. There are two types of use. One is called predicate use. Another one is called computation use. What exactly is predicate use? This a usage node use vn is predicate use denoted as a p use if and only if the statement n is a predicate statement. If it is a predicate statement, like predicate statement is nothing but the condition. If condition, for example, if I take if condition is considered as a predicate. Based on that one, either it will go for true or false. That's what it's called if or predicate usage. Okay. So another one is called computation use. So other than that one is considered as a computation use or C use. P use is nothing but predicate use. C use is nothing but computation use. Okay. There are more definitions will come. Same. There are actually meaning the same. Okay. One, for example, a definition use path is there. A definition clear path is there. What exactly is the definition use path? A definition use path with respect to a variable v is denoted as a du path, right? This is very, very important definition. Du path, right? What exactly is du path? Definition use path. This definition use path is a path in the set of all paths in P such that for some variable v which belongs to v, capital V, there are define and usage node. Define VM and use Pn, such that m and n are the initial and final nodes of the path. So the main thing here is there is two nodes, okay, m and n node. So m is a initial node and n is a final node. If there is a path between m to n, then that should be defined path and use path. I mean, at m the node is actually defined, at n the node is actually used. If there is a path between those two paths, then we can call it as a definition use path. Okay, what is definition clear path? DC path. This DC path is a definition use path. Of course, it's a kind of definition use path only. But here, the initial and final nodes v of m and v of n such that no other node in the path is a defining node of v. So in the definition use path, a defined point is there and use point is there. There is a connection between defined path as well as use path. But in between the defined path and use path, there may be another defined path will come. But here in the DC path, only one defined path is there, only one use path is there. Okay, there is no other defined path with respect to m and n. Okay, so if the path contains only one defined path and only one used path, then it is called defined clear path or definition clear path or DC path. So this is the main difference between DU path and DC path. DU path, it may contain many definition path, but only one usage path. But here in the defined clear path, there is one defined path and only one clear path. Okay, that is the main difference between DU path and DC path. For example, commission problem is there. Okay, so I written this commission problem by representing each statement as a line number. This line number serves as a nodes. Okay, first node program commission definition is there. Second is of course there is a declaration statement, right? RR declaration statement. Okay, there are actually how many statements are there? Totally 43 statements are there, right? 43 lines are there, so 43 statements are there. Each 43 statements actually considered as a nodes. Okay, if you want to write the program graph for this one, just write this one, right? Why it starts from 7? Check here, it actually starts from 7, right? Why? Just consider here, right? Here the first program commission input output is actually what? Some kind of declaration, right? I mean, it's going to give some idea about what is actually a program commission function, okay, which accepts two parameter input and output. Okay, so the line, I mean the statements 2, 3, 4, 5, 6 all are declaration only. There is no definition, only declaration. In the second statement, I declared logs, stocks, barrels as integer. In the third statement, I declared log price, stock price, barrel price as real. So in the same way, I declared many variables here, right, up to the line number 6. That's why there is no need to start from line number 1. 1 is actually function name, and the rest of the 5 from 2 to 6 is only declaration. So the statement number 7 or node number 7, log price is equal to 45. That is actually the definition. I'm going to definition is nothing but I'm going to assign the value 45 to the variable log price. From this point, the actual program graph will start. Okay, you can just see here 7 to 13 is a sequence. There is no path will come. There is no construct, or there is no loops will come. Right? There is no condition will come. You just check here in the which loop 14. 14 is actually what? While loop, right? Up to 13 only 7, 8, 9, 10, 11, 12, 13 all are definitions only, is sequence of executions. But when you check the line number 14, the node number 14, it's actually what? Loop, while loop. That's why either it will follow 15 or it will follow 21. Just check here. Either it will follow the line number 15 if it is true, 15, 16, 17, 18, 19, 20. Again the loop will be getting repeated until the role the condition will become false. I mean the condition, what is the condition here? While not lax is equal to -1. If until if you give -1 to this one, I mean if you give not other than -1 to this value, for example if you give 0, 2, 1, 2, 3, 4, 5, 6, any number other than -1, then only it will follow the node 15, 16, 17, 18, 19, right? 20, I mean 20. Once you give -1 to this one, it will comes out of the loop. The loop, while loop will become false. Okay, the sequence, the execution sequence will comes out of the loop. It directly go to the node number, which one? 21, right? So it will going to give the output lag, sold, lag, total. It's the same way, right? Same way 29 also some while loop is there. You can check here. 29 is name what? Which one? Is if condition. Okay, again 34 is also another if condition. Again okay, these are all some conditions are there. 29, 34 and all, right? You can check here. So if you want to write the define and use nodes for this one, just type the variable in one side, define at node in one side, and user at node in one side, right? The lag price total actually defined at variable 7. You can check here. The lag price is actually defined at variable 7. Lag price is equal, I mean the line number 7. But where it is actually used? It is actually used at line number 24, right? At the line number 24 only I use that one. Output 24. Lag sales is equal to lag price into total lags, right? In the same way, total lags is also defined at 8, 10 and 16. You can check here there. Used at 16, 21, 24. The same way, lags sales. And that. So while writing define and use node, in one row write variables. Most probably in exam, this program only they will give. Write variables here, variables names here. Where actually you define that one. Write that line number here. Where actually you use that one. Write the user point there. Okay. That you will get 8 marks, 8 to 10 marks. Okay. This is actually some path, du path for lags actually. You can check here for lags. 13, 14 is the du path for lags. 13, 14. Input lags is there, and 14 lags you use. Only 2 points only use that one, right? For lags. There is one first path. In second path use 13, 14, 15, 16. Right? Check here. Second path 13, 14, 15, 16. Lags 15 also use the variable here. Lags here. I mean in 16. Total lags is equal to total lags plus lags. Okay. That's in third line. Just check here. Third line. 19, 20 and 14. 19, 20 and 14 also you do. Where is 19? 19 input lags, 20 end while, right? It will directly go to after, since it is a loop, again it will go to this condition, while not lags, right? That's why it's 19, 20 and 14. Okay. Again in 19, 20, 14, 15, 16. This is another du path, right? where you actually define, where you actually use. In the first point, in the first path, you define it at 13 and use it at 14. In the second P2 path, you define at 13 and use it at 16. In the third P3 path, you define at 19 and use it at 14. In the fourth DU path, you define at 19 and use it at 16. You can check there. Define it at 19 and use it at 16. I will check the fourth path. Define it at 19, use it at 16. Right? Defined at 19, right? 19 and defined. Input lags, right? Input lag I defined. But I am going to use, since it is a loop, I am going to use 19, 20, 16 also. Total lags is equal to total lags plus lags, right? Defined at 19, use it at 16. That's why it can be has many sequences like this. In this case, I have 4 paths for lags, right? All are actually definition clear because there is one defined path and only one use path, right? First path you can check here, second path, third path and fourth path. That's why they have clearly given this one. 13, 14, you can check. Define it at 13 and use it at lags for lags 14, right? Use it at 14. That is one path. Again, define it at 13, use it at 16, right? 14 also used. 15 I didn't use that one, but 16 I used. That's why 13, 14, 15, 16. Again, but I defined it at 20 here in this case, the third P3 path, right? I mean defined at 14, but it will go into 19, 20, again 14, right? Also rest of the program you can just see, right? So these define and use test cases, if you want to say the define and use test cases, the technique I'm going to use, the technique actually they use here is for particular variable, find all its destination and usage nodes. That is the first point, right? Find all its definition, okay, not destination. Find all the definition of a variable and usage of a variable. And next thing is find the DU path and DC path among these. For each this path, devise a suitable set of test cases. Okay, based on that one, devise a suitable test of test cases. The noting point here is DU path, DC path have both static and dynamic interpretation. Okay, here static is nothing but just as seen in the source code, right? Simple. Dynamic is nothing but must consider execution time flow, right? Static, of course, only which is present in the program. In dynamic, while executing the program. These definition clear paths are easier to test. Okay, this instead of DU path here, this definition clear since it is only one defined node, only one used node. It is actually easy to test. No need to check each definition node as is necessary for DU path. That's why it's very important here. Okay. So in the next class we're going to cover the another approaches like coverage matrix based on DU paths and all. Okay. Thank you.